So I gave you the expression 12 sine 3x cos 3x. And it said apply, use a double angle formula to rewrite the expression. Okay, there's lots of double angle formulas, I guess, but the two most popular are that cos of 2 theta equals cos squared theta minus sine squared theta, and then sine 2 theta equals 2 sine theta cos theta. There's a couple other incarnations of this where you change cos squared with 1 minus sine squared, etc. And then there's tan 2 theta, but obviously it's not tangent 2 theta. So of these two, which one should I be looking at? Sine, right? This matches up pretty closely to, this guy says 2 sine theta cos theta. This guy says 12 sine 3x cos 3x. So if I were going to try to match this expression up with this right side here, what would theta have to be? 3x, right? Because the theta here, the angle inside is 3x. So this theta I'm going to have to think of as 3x. So then if I have exactly 2 sine 3x cos 3x, if this is what I have, then what should be on the other side? Yeah, you double the 3x. It's a double angle formula. It takes this single and doubles it. So if it was 3x, this will be sine 6x. But I don't have 2, I have 12. Right? So how do I fix up this 2 on the outside? Multiply both sides. Take this equation, this identity, this is always true, and multiply by 6 right here. So then this will become 12 sine 3x cos 3x equals 6 sine 6x. So this guy should equal 6 sine 6x. So, I have a couple of announcements. I'll take questions, but let me get these announcements out of the way. First thing is our final exam is coming up, not too soon, but soon enough, right? It's the second week in May. I'm going to post a review sheet for you this week, by the end of this week. Okay, so you can get started on that as soon as I post it. So that's announcement one. Second announcement. On the Monday before the final exam, instead of taking questions, I'm going to give you a practice final exam. So you'll come in, and for the first 40, 45 minutes, you'll take an exam. And then for the next half an hour or 40 minutes, we'll go over it. Okay? I've had a couple requests of people who want to sort of know, who want to just basically do a practice exam because they want all the conditions to be the same. So I think that might help you guys out a little bit more than me answering questions and you just writing it down and not even thinking or understanding. Of course you can ask me questions. Since I'm posting the review sheet this week, you can ask me questions whenever they come up as you work on it. But on the Monday before the final exam, I'm going to give you a practice exam. It won't be the same length because I want to spend time going over it as well. But it'll be about half the length and I'll give you half the time. So this way you can see if you need to work faster or slower, see if you're already prepared and don't need to study anymore, whatever. Okay, it'll give you an idea of what's coming. So any questions about the final exam or really any questions at all? So, yeah, go ahead.
Yeah, the quiz, the last answer was number 5. It kind of threw me off with the radians. I didn't really...
Yeah, let's go over number 5 then quickly. But anything about... Yeah.
Did you say that the final is going to take over one of the previous tests?
Yes. So whatever score you get on the final exam, whatever percentage you get on the final exam, if it's more than one of your other tests, I will replace the other test with your final exam percentage. The final exam will be comprehensive, meaning it covers everything from the beginning of time, but I will try to make it a 50-50 split, meaning 50% of it will be stuff we didn't have on another test, and 50% of it will be stuff we have had, meaning at least the same content. Number 5 on the quiz asked you to use half-angle formulas to determine the exact value of the expression, and I gave you cos of 3 pi over 8. So the way, so this is from quiz 9 again. So the way this works, well, first of all, it tells you to use half-angle formulas, so you should have in your head somewhere that cos of 1/2 alpha is equal to plus or minus the square root of 1 plus cos alpha over 2. So this is the guy we're going to apply. In order to apply this, though, you have to have this exact format with a 1/2 times an alpha, with a 1/2 times an angle. So you're going to have to rewrite this as cosine of 1/2 of something. So whatever this alpha is, I mean, the logical way to figure out what alpha is to solve the equation that 3 pi over 8 has to equal 1/2 alpha. Right? If you solve this, you would multiply up the 2. And so you would see that the 2's cancel, and alpha must equal 6 pi over 8, or 3 pi over 4. So that's one way to do it, right? That's one way to see that this is really cosine of 1/2 times 3 pi over 4. Anybody else have a... I mean, the formula is kind of always the same for these half-angle problems. Because you're putting a half out in front, you have to double what you started with to make up for this half. So whatever, I don't care what this is, if you want to write it with a 1/2 in front, you have to double it. So for example, if I wanted to express cosine of, I don't know, 12 pi over 17, but I wanted to write the angle with a half out in front, what would I put here?
24 pi.
Yeah, you double this, right? Whatever this is, you double it. So if you double a fraction, you multiply the numerator by 2 and the denominator by 1. Because if you reduce here, the 2 on the bottom and the 24 on top will get you back to where you started. Okay, so to make up for this 1/2, you double the original angle. That's what happened. Then after that, you have to actually apply the formula. But that's kind of the starting step. So now how does the formula work? We're going to make this plus or minus the square root of 1 plus cosine. Instead of putting alpha, I'm going to use 3 pi over 4, right? That's my alpha. So I'll put 1 plus cos 3 pi over 4 over 2. Let's go ahead and decide this plus or minus out front. What does this depend on? The original angle, right? Because at the end of the day, I'm trying to find cosine of 3 pi over 8. Right? And 3 pi over 8 is in which quadrant? The first quadrant. How do you know that?
It's less than half the...
Yeah, 4 pi over 8 would be right here. Right? Because 4 pi over 8 is pi over 2. So 3 pi over 8 is a little bit less. So I know that this angle is in the first quadrant, which means the final sign, S-I-G-N, the final sign over here should be positive or negative? Positive. Because cosine, well, everything is positive in the first quadrant. So you pick the plus. Then you actually have to evaluate cosine of 3 pi over 4. What's cosine of 3 pi over 4 equal to?
Negative.
Yeah, so cosine 3 pi over 4, if you look on your unit circle, here's 3 pi over 4, so this will be negative root 2 over 2, root 2 over 2. So this will be equal to 1 plus negative root 2 over 2 over 2. Positive out in front. And then you have to do some simplification here. So for example, this 1, I would change into 2 over 2. And then I would add my numerators here. This will become the square root of 2 minus root 2. 2 minus root 2. All of that's going to be over the common denominator of 2. And then all of that again is over another 2. This becomes 2 over 1. You flip and multiply. So when the 2 over 1 gets flipped up, it becomes a 1 over 2. So you get a 4 on the bottom and the same thing on top. And then when you do the square root of 4, you get 2. That should have been the answer. It's like B.
Forgot the 4.
What I do?
Did you change the 4 to a 2?
Yeah, because I took the square root.
Oh.
Because the square root's over the whole thing. So square root of 4 becomes 2. But then on top, I have 2 square roots there. So, yeah, any questions about this? What else can I help you with? Trying to any problems? Any other problems? No? You ready? You good to go? Ready to move on? All right, far be it for me to slow you down.